So, hello everyone. My friend Abhishek and me were working on this project. So, we tried to create a graph data store to build and maintain a large corporate and political network dataset. So, so we believe that the democratic government is actually consisting of various powerhouses, like the powerhouses of politicians, powerhouses of corporates. And so we wanted to study this distribution power of these among these powerhouses. So we tried to collect the data and push it into a data store. And from this data store, we wanted to extract information and show it to the public so that it enhances the governmental accountability and transparency. So here is a big picture of our entire system. At our heart, we have a data store which consists integrated information from collected from several sources and inserted after cleaning. And from this data store, we actually showed to the common mass analysis or showed them wikis or visualization, etc. We also provision for some API calls so that data technicians, data enthusiasts, journalists, they can use them for use the data for their own purpose. So the work we did actually can be uh, divided into three steps: the social network creation, wherein we collected the data; the design of power elites, wherein we designed a web app; and the visualization analysis, wherein we analyze the results given by our system. So to begin with, these are some data sets we used for the purpose of collecting the data. For corporates, we actually collected from the official sites of Ministry of Corporate Affairs, Capital Line, Company Wiki, etc. For political data, we look at MyNeta, which is a website by Association for Democratic Reforms, and the Lok Sabha Rajya Sabha websites. Our collection methods were largely running some Python scripts of using some libraries or frameworks, and we also collected manually, and sometimes we also used bootstrapping, wherein we used our own scripts to generate a larger dataset from a seed dataset, from a smaller dataset. So after the data has been collected, the main issue remains that of modeling the data. So for modeling, we have used a graph database as our core to data store. So why graph database? Because it stores relationships at a physical level. So giving queries on relationships is much easier, unlike in relational database where we had to give nested joins, complicated SQL queries to do the same. And moreover, the Neo4j graph database is NoSQL, so we can allow data with varied attributes. So here we see a small representation of the graph database where we have objects like entities and relationships. Each entity and relationship has got some labels and some properties. So there are some common labels of the entities like the entity label, and some common properties like the name, UID, aliases not shown here, and there are properties like rel ID for the relations also. The bottom one shows a specific entity business person which is connected to another specific entity company with a specific relation between them with label what's in. Moving on to the next slide, we have data integration. Like when the data is collected, they are collected from different sources and they have different schema. So how to push this into our data model, our graph data model? So we have done this like many other systems. We have used a REST API with some JSON payload. So basically the data gatherers has to adhere to some common JSON format before pushing in the data to the graph database using the REST API. So this is the JSON format followed by us. Since we are pushing in a graph data, there is an entities array and there is a relations array with certain properties useful for inserting. And since there is no unique IDs among the data sets, among the entities of the data sets, so we have to resolve and merge the entities which are similar. So two important operations out here. So one is the match score, which gives us a metric of how much similar two strings are. We are using Jarrow-Winkler and double metaphor for matching, and another is that how to compare the records. So if we compare the records one by one, which is basically same as linear search, it is very time consuming, and binary search is not possible out here since there is no definite order, and so indexing comes to the rescue at this juncture. We basically index some of the fields of our graph database like aliases and labels, and some fields we generated like aliases phonetic, which is phonetic indexes of the aliases, and keywords which are generated from the properties of the entities, and we actually gave give AND queries based on these fields to triangulate the entity. So now we go on to discuss the design of the PowerSheets web app.
Thank you, Murtya. Hello, everyone. My name is Abhishek Agarwal. See, what we are interested in the long run is to have a single, non-duplicated, integrated graph of different connections between the top 1% of the Indian economy. And we want to be able to incrementally update this graph with authenticated new information from time to time. Let's call this primary data source as the core data store. We have two graph databases in the system. One is the core data store and one is the crawl data store. Any new information in the system through the wiki or from the data gatherers is first pushed into the crawl data store. We have also opened up a REST APIs to be able to crowdsource any kind of connected data from different people in different groups, and that goes into the crawl data store. Any new information from the crawl data store is first resolved and verified, and then only it is pushed and merged into the core data store. We take the help of Apache Solr and IndexedDB in the backend, and we also crowdsource this process through human verifiers. And this is how we try to solve the problem of data resolution and data verification. Here's the profile of Jaidev Kalla from our wiki. One can also see his family and business connections over here, what organizations he works for, whom he is related to. One can also generate such visualizations using our system. Using the wiki from our system, registered users can add new nodes, new relations, can edit old nodes, old relations, can add or edit properties, can add labels. All these suggestions go to the crawl data store in the end. The end result of the entire resolution and the verification task is that for a node in the crawl data store, we want to assign it a UUID from the core data store. And similarly for the relations, we want to assign it a real ID. Here's what happens. A node is picked for resolution from the crawl data store using some selection strategy. Possible matches of that node are generated by searching similar nodes over the entire graph using Apache Solr and IndexedDB, and then those options are shown to the verifier for that crawl node. The verifier, using the source URL and investigation on the web, can affirm and pick a particular matching node from the possible list of options. Verifier is then shown the diff between the core entity and the entity from the crawl data store. Any new labels, any new properties, any conflicting properties are all shown. Verifier on his whim then selects any new information that he wants to be pushed and merged to the matching node in the core data store. Any update on the core data store has been well documented and accounted for. Users can view the history of entities and relationships they are interested in over the time. They can see any change in the old property, they can see any new properties, they can see who pushed the data, who verified the data, they can see the push date, the date of crawling, the source URL, etc. We have about 1,50,000 nodes and about 4 lakh relationships in our core data store. Let's see some interesting visualizations that we have generated. Here we describe the influence network of the Jindal Group using director sharing data. These small dots are directors, so this person is on the board of director of this company and this company as well. As we can see, Jindal Group is connected to Bharti Airtel, is connected to Reliance, and to ONGC through director sharing. This is the entire Ambani empire in a graph. See how Kokila Ambani, the mother of Ambani brothers, is also a director of certain companies. See how interestingly Tina Ambani, Neeta Ambani, and also their sons and daughters Isha Ambani, Akash Ambani, Anand Ambani are sharing companies. Now this is an amazing example where art and business come together. Shwetananda Bachchan, who is the daughter of Jaya Bachchan and Amitabh Bachchan, is married to Nikhil Nanda. She also even shares certain companies with him. Nikhil Nanda is the MD of the Scotch Group. He is the son of Ritu Nanda, who is the daughter of Raj Kapoor. Ritu Nanda also has a daughter called Nitisha Nanda. So in a way, Ranbir Kapoor, Nitisha Nanda and Nikhil Nanda are cousins. Another example of marriage comes from politics. Tej Pratap Singh Yadav, grandnephew of Mulayam Singh Yadav, married Raj Lakshmi Yadav, who is the youngest daughter of Lalu Prasad Yadav. Not only marriage, people also form big relations through dating across powerhouses. Here we see how Preeti Zinta dated Nes Wadia some time back and was on the board of directors of Kings 11 Punjab with him. Wadias own the Britannia, Go Air and Bombay Dyeing. Here in the topmost graph we have Kamal Nath, who is the member of Indian National Congress and member of Parliament in the 16th Lok Sabha. His daughter Neeta Puri is married to Deepak Puri, who is the MD of Mozabeer. Also, in the bottommost graph, we have the first family of Indian politics, Sonia Gandhi, son Rahul Gandhi, daughter Priyanka Gandhi, and her husband Robert Vadra, and his companies over here. A lot of ground has been covered, but still, a lot of ground still needs to be covered in such a project. More data needs to be pushed, PPP data, bureaucratic data, etc. More analysis needs to be done on the social network that we have created. We can always build an inference engine around family relations, which can suggest new relations between entities and stuff like that. Thank you so much for your time.